So we've looked at systems of equations, multivariable equations, and we looked at how we can solve them um, using a couple different methods. Now we're going to take a look at how we can use matrices, which is the plural of a matrix, to solve systems of multivariable equations. And so whenever we are describing a matrix, we always read that it's m by n, which is the rows by the columns. So whatever number comes first indicates how many rows there are, and whatever number comes second indicates how many columns there are. And then each of the elements in the matrix are called entries. Okay, and so for example number 1, we are going to rewrite this as a matrix, and all you're doing is taking the coefficients. So we have 5, 1, 7, and I try to keep them in order so all the x's are in line. Well, and you need to keep them in order, but try to keep them aligned is the best way to do it. So then for our z's, we have -1, 3, and 7. And then often you'll see where there's the equal sign, some like a dotted line there. And then 8, -6, -3. And so this would be a 3 by 4. And this is what's called the augmented matrix because of that, that's matrix, because of that dotted line that shows what those equations are equal to or expressions are equal to. The coefficient matrix would just be the beginning part of it without the equal column. So this would be called the coefficient matrix, and it's a 3 by 3 because there are 3 rows and 3 columns. Okay? All right, so that's all we had to do for number 1. We weren't solving anything. Let's take a look at number 2. This is where we are going to actually solve the system. And there are 3 different operations that we can use with matrices. We can switch 2 rows around. So like you could switch the first and the third. You could multiply a row by a non-zero constant. And you can add a multiple of one row to another. So that's kind of like, well, yeah. Okay, so the first thing we're going to do here is I'm going to change this into the augmented matrix. So we have 1, 2, 3 in the first column, 3, 7, 10 in the second column, 4, 5, and 4, and then 7, 10, and 27. So this is a 3 by 4 augmented matrix. Okay, so then the first thing I'm going to do, and this is going to take up quite a bit of space. I used pretty much my whole paper. So I am going to just rewrite the first row and the second row. All right, and then for the third row, I am going to take row 1 and subtract row 3. So if we look at our original matrix, we have 1 minus 3, which is -2. We have 3 minus 10, which is -7. 4 minus 4 is 0. And 7 minus 27 is -20. So that's the change that I made there. Okay. All right, so in the next one, again, I'm going to keep the first row the same and the second row. But then for the third row, I'm going to add row 2 and row 3 from the previous matrix. So 2 minus 2 is 0, 7 minus 7 is 0, and 5 minus 0 is 5, and then 10 plus negative 20, or I should have said 5 plus 0. 10 plus negative 20 is negative 10. Okay, so then for my next matrix, so far I have not done anything with the first two. Still not going to for this matrix. So I have 1, 3, 4. And the more you get used to using matrices, the more you can combine steps. I'm not doing that because I don't want to confuse you. But once you kind of get the feel for it, you can start combining steps. All right, and so now for the last one, I am going to take 1/5 of the previous row 3. So 1/5 of 0 is just 0. 1/5 of 5 is 1, and 1/5 of negative 10 is negative 2. So now we actually have our z value. We know that z is equal to negative 2. Okay? So then what we can do is if we rewrite this matrix here, and I'm going to leave the first one alone. Okay, and I'm going to leave the second or the third one alone. But for the third or the second row, I'm going to take negative 2 times row 1 and add that to row 2. Okay, so in the previous one we had 1, 3, 4, 7 for row 1, so we're going to double that, and then row 2 was 2, 7, 5, 10. Okay, so if I double the first row, we'll make it negative 2 times that. So negative 2, negative 6, negative 8, and negative 14. So those are basically the numbers that I'm using. And I'm adding that to row 2. So negative 2 plus 2 is 0. Negative 6 plus 7 is 1. Negative 8 plus 5 is negative 3. And negative 14 plus 10 is negative 4. So now I can take that row and I can plug in my z equals negative 2. So I have y minus 3 times z, which is negative 2, equals negative 4. Okay, so y plus 6 equals negative 4. So y equals negative 10. And then I can take my z and my y and plug them into the first equation, which was x plus 3 times y, which was negative 10, plus 4 times z, which was negative 2, equals 7. And that was the original first equation. So x minus 30 minus 8 equals 7. So x equals 45. So our answer is the set of it's not really an ordered pair, the ordered triple of negative 45, negative 10, negative 2. Sometimes when you try to go too fast, you end up saying the wrong thing. Okay, so that is how you can solve the system using a matrix. And we will do example 3 in class together.